Good morning, good afternoon, and good evening to wherever part of the world that you may be. Thank you for tuning in today to today's session of Scaling MLOps on Kubernetes with Amazon SageMaker Operators. Regardless of where you are, 2020 has definitely been a trying time. If there's any way that we at AWS can help, please feel free to reach out to your account manager or to anybody on our team. We really love seeing how machine learning can better impact the world. Today's session will be led by myself. I'm a senior product manager on the SageMaker org, and specifically I lead our open source integration and products. I am joined by my friend Shrivastsan, and I will let him introduce himself.
Hello everyone, my name is Srivatsan and I'm part of the engineering team behind Intuit's ML platform.
In today's session, we'll be talking about how Intuit is leveraging machine learning across all of their different product areas. We'll talk then about MLOps, the idea of taking models that you may have been building in an experimentation state or locally and taking it into production. Next, we'll be talking about how open source tools integrate with the SageMaker machine learning platform, this managed service ecosystem on AWS. And then next, we'll talk about how you can integrate your own custom internal tools that are built off open source technologies with SageMaker. And then finally, we'll be doing a demo and a wrap-up of this entire session.
Thank you for the introduction, Alex. To give a brief overview of Intuit, we are the makers of finance and accounting software such as TurboTax, QuickBooks, and Mint. Our products serve the financial needs of consumers, small businesses, and those who are self-employed. Intuit's mission is to power prosperity around the world with an AI-driven expert platform, and that mission has never been more important than now. A lot of experiences of Intuit products are driven by ML. For example, ML powers the search bar on the TurboTax website, which is used by millions of people to file their taxes. Intuit ML also enables small and medium-sized businesses to better predict their cash flow. And we have helped many entrepreneurs plan effectively during COVID-19, and this is something we're extremely proud of. Intuit has also been a leader in ML using SageMaker. We have been leveraging SageMaker for machine learning predictions since an early private beta. We have also tested nearly every feature of SageMaker from the beta times onwards. We have showcased our ML platform at various conferences and forums such as KubeCon, OpML, and other ML meetups. We are also the creators of the open source Argo that is used for data pipelines and ML orchestration. And Intuit uses an entirely Kubernetes native ecosystem across its various services and products.
The question that many customers are asking me now is, what is MLOps? MLOps is the process of taking a model developed in a notebook or local environment and efficiently managing the deployment into production. It's one thing if you have a lot of models at your disposal that are trained in local notebooks, but unless it could be served on an endpoint efficiently, gracefully in terms of being able to A/B test and roll out with efficacy without impacting users, all these models cannot be used for serving the core business. So the idea of MLOps really is the process of deploying models into production. And for this, Amazon has built a product called the SageMaker Operators. The SageMaker Operators allows customers in Kubernetes environments to access SageMaker for all of the infrastructure and DevOps without having to provision any of these resources on your own. And specifically, you can tie this in to your Kubernetes environment following a GitOps pattern and approach by creating custom resource definitions, also known as CRDs, that allow you to deploy models, train models, do batch processing jobs, stream and view logs, and then also any of the other features available in SageMaker directly from your native Kubernetes interface. And what this ultimately allows you to do is you can submit the same job over a YAML file and take advantage of the full cluster of Amazon SageMaker. And this can attach into your Kubernetes environment natively without any major changes to your code. And the benefit of leveraging a tool like SageMaker is you can get your CPUs, your GPUs, or custom chips like Inferentia on AWS, while also having the benefits of most of the major tools in open source as a managed service. All the different tools that you might see in open source today, SageMaker has a version of that allows you to take advantage of our managed infrastructure under the hood. So for a side-by-side comparison, you can see different steps within the model lifecycle. Specifically here, you can see at the very top, for something like feature processing and feature loading, you have the Spark operator in open source. And within SageMaker, you have a tool called SageMaker Processing that has the latest Spark container available, where you can do real-time transformation of your underlying tabular data and prepare it for machine learning training. And when you leverage SageMaker for your machine learning processes, the experience for your developers is actually pretty similar. On the left-hand side, you can see a Kubeflow serving operator. It allows you to define the name of the model, the storage location, and everything below that in terms of the instance types, the sizes, the replica sets are handled on the Kubernetes level, or also at the overall cluster level. By leveraging SageMaker operators, you can do the exact same deployment of a model, except you can configure this all natively from within your operator itself and the custom resource definition that you submit. So specifically here, you can see that we're deploying on the US East 2 region with a single variant in terms of the model traffic type. And we're pulling in a model that is from S3 that we named XGBoost model. And we also attach an ARN, an ARN, for the permissions that the model is allowed to serve with on that instance endpoint. We even include different tools like Autoscaling Endpoints, a common feature if you use EC2 regularly. And you can auto-scale your endpoints similar to a replica set, except with even more fine-tuned granularity. So once again, on the left, that is attaching a auto-scaling for the KF serving operator. And on the right, you can see that we're attaching an auto-scaling policy to the same endpoint that we showed in the previous slide. You can scale out the capacity in terms of number of instances. You can define the custom metrics. And also, you can change around the cooldown in terms of how quickly the instance scales up and scales down. What this allows you to do end-to-end from the SageMaker operators is remove a majority of your DevOps work within your machine learning platform, while also being able to take advantage of the many different features that you can get in SageMaker. For instance, if you leverage SageMaker operators into your ML platform that's built on top of Kubernetes, you can use things like model monitoring, which allow you to baseline training data using SageMaker. And then from there, you can sample new inference jobs that are applied against your endpoint. And whenever the values deviate statistically away from the expected norms, you can kick off an alarm through CloudWatch, which then can invoke a Lambda job, and then you can retrain that entire model. And all of that lineage can be tracked through SageMaker Experiment. And by leveraging SageMaker and open source, you get the benefits of both worlds. From SageMaker, you get the fully managed infrastructure, tools like managed spot training, scalable inference endpoints, automatic model tuning and hyperparameter optimization, model monitoring, and things like first-party algorithms that allow you to use common models like XGBoost natively within SageMaker. While also at the same time, you get the benefits of Kubernetes, which allow you to do things like hybrid infrastructure, both on the cloud and on-premise, You can also reuse existing infrastructure. For instance, if you have a Kubernetes cluster serving your applications, you can tie that in with SageMaker and have ML capabilities without any additional work. You can also get full portability and the composability from the standard YAML configurations that is pervasive in GitOps. And I'm going to hand this now over to Srivasan to share more about how Intuit does this within their ecosystem.
Thank you for this great introduction, Alex. I cannot wait to use the capabilities provided by the SageMaker operator and scale Intuit's machine learning platform. What does scaling MLOps for Intuit mean? Currently, there are over 400 models that are actively used in production, and with many of them getting trained every day. Intuit's feature store hosts over 8,000 features. Collecting features from the diverse sources of data at Intuit is the responsibility of the streaming and batch feature processors, which totally collect a staggering 15 billion plus features every day from Intuit's products. We now want to take this platform to the next level to power more prosperity for our customers. As we think about MLOps, a question that keeps coming to our mind is how can ML practitioners focus on their craft, which is data science, and not worry about the ML ops part of it, which is under the line. Alex showed an elegant way by which the operators can enable ML practitioners to access the managed service natively with Kubernetes YAML-based declarative specifications. As an ML platform, we want to simplify that experience further. How can we reduce the YAML configuration so that our data scientists have to provide just enough information, no more and no less? In an enterprise, there are many challenges that a data scientist have to overcome, and without an robust MLOps, this becomes difficult. Some of these are around cloud infrastructure management, enterprise security and compliance, observability, and building clean interfaces, be it web, API, SDK, or CLIs. How can we simplify all of these to provide an elegant MLOps experience? This is where Intuit has built a full-fledged machine learning platform. This platform automates and abstracts the hard stuff from our data scientist. The platform offers capabilities for the entire ML lifecycle, starting with feature processing, storing these features in the feature store, training on these features, evaluating the trained models, inferring in real time and batch fashions, and providing model efficacy feedback and feeding that back into the lifecycle so that the next version of the model can be much better than the previous version of the model. The ML platform has provided significant benefits for enabling ML ops at Intuit and is a driving force for accelerating the AI vision for the company. On the flip side, the technologies landscape that is stitched together in order to achieve this surfaces multiple technical problems for the platform. How do we do consistent auth-in and auth-z? How do we do clean roles and handoff between roles across these multiple systems? Compliance and security has to be uniformly applied across all of these systems, and how do we enable that? New features and capabilities that SageMaker enables need custom development in order to enable them in front of our customers. And how do we make that simpler? Is there a better way to do this? Can we tie these all together? We looked around and we realized that Intuit has a heavy investment in Kubernetes with our Kubernetes service and Argo workflows and Argo CD ecosystem. We also use Kubernetes operators for various things. For example, we use the Argo operator extensively in our training and batch pipelines. We use the SageMaker operator and the Spark operator for various data processing. Can this ecosystem be better when they are all tied together? That's why we are starting off with Kubernetes native MLOps. Using the Kubernetes operator-based approach, the platform becomes much simpler and it enables us to accelerate AI at Intuit to even greater heights. We are able to produce a single reusable control plane based on Kubernetes and abstract out platform concerns such as security, compliance, cost efficiencies so that they can be built once and reused across the platform. With this approach, the time to market for new features and capabilities offered by downstream systems, be it SageMaker or Argo or Spark, is extremely quick and efficient as the operators go through their upgrade cycle and the benefits are realized by our customers. To go down a couple of levels, this is how the platform declaratively expresses workflows that are easily composable. What you're seeing here is a snippet of an Argo workflow that is used for training one of our models. The Kubernetes programming model allows for elegant implementation of the platform, which constructs such as mutating and validating webhooks, custom operators, etc. We are on a journey of reworking the platform to work with the Kubernetes programming model, and we will see a demo of how this will work later in this talk. Customers interface with native Kubernetes manifests corresponding to the operators, be it SageMaker, Spark, or Argo. In this picture, we are seeing a native SageMaker CRD of a hosting deployment. This allows for a lot of flexibility for our customers while the platform does its work in the background. Let's now see how a demo of how Intuit's ML platform ties all of these pieces together with a simple example. In this demo, I'm going to show how Intuit ML platform leverages Kubernetes and AWS SageMaker operators for managing model lifecycles in a Kubernetes-first manner. What do these terms mean? A look at first principles on which the ML platform is built. The platform is designed to allow model developers to focus on their craft rather than having to worry about the MLOps part of it. There's a clear separation of concerns between platform and developer. The platform leverages Kubernetes operator objects natively and for all runtime configurations of the model. And it also provides a GitOps foundation so we can provide transparency and operational control to the data scientists and MLEs. In a Kubernetes first world, the role of an ML platform is extremely important because this platform now provides capabilities and addresses platform concerns such as cloud resource management, VPCs and network controls, security, logging, monitoring, and providing a robust CI/CD platform. I'm going to walk you through a model code repository. This repository contains the code of an ML model that predicts the odds of credit card approval. This model is based on TensorFlow and is representative of a real-world model that Intuit uses in its product. This model will be trained using the latest available datasets. The code for this model is under the folder called credit card approval, and here you can see that it has 3 files. One is the batch prediction, there's an online prediction, and there's a training code. All of this is the code that the data scientists work on and they are focused on. Let's look at the training code. This is the standard TensorFlow model that the data scientists have written an awesome algorithm to go and predict the success rate for a credit card approval. Other than that, this repo has a few other files that tie it into the ML platform. Of interest is the Jenkins file. This Jenkins file provides a robust CI/CD mechanism for taking this model from code and putting it in a fully operational environment. So this CI/CD mechanism makes sure that the Docker files are secure and all the quality gates have passed successfully. This is a sample run of the CI/CD mechanism. Going back to the code, we want the data scientists to focus on these 3 files and make sure that they are writing the best algorithms that can solve our customer's problem in the best possible way. Everything else is taken care of by the platform. What do we mean by that? We also said that we want to separate the platform concerns from the developer concerns. This is what the developer, the data scientist, looks at and is operating on a daily basis. The platform concerns are now separated into a separate repo called the config repo. Here is an example. The config repo contains files that declare how the training should be run, how the hosting should be run, and how all of these should get tied together with a pipeline. Let's look at how the training YAML is defined, and let's go into some details here. The YAML file here is a native Kubernetes CRD as defined by AWS SageMaker. The kind is a training job. This file allows our data scientists to specify attributes for deploying the model to production. For instance, the resource config. How large should an instance be? How many of those instances should be there? And how large should the size of the volume that is attached to the instance be? It also specifies other things such as the data sources, from where to read from and where to write to, the training output. There are other things such as VPCs, network configurations, and security groups, which are missing from this picture. If you went to normal SageMaker, you would have to provide all of those details, but they are not here. The reason they're not here is because the platform takes ownership of those. And we will look at how that is applied in a little bit. Let's now walk through what if a data scientist needs to make a change. For instance, I now want to change the size of my instances so that I can run my training faster. I'm going to make this change directly on GitHub and commit the changes. This then triggers a webhook. This webhook is how GitHub communicates to the platform to say that, hey, something has changed in the model code and config, and we need to take care of that. So as soon as this code is committed, this gets picked up by our webhook, which then triggers an Argo workflow. And here is a ping that the platform has sent onto our Slack saying, hey, I have started a training because the training configuration has changed. We use Argo extensively in the platform for training and batch inference jobs. Here you can see that the training for this model has already started, and this pipeline will now invoke SageMaker and start running the training job in SageMaker. As you can see, the training job has already started, and this job would have provided SageMaker with all the configurations that the developer provided. Here is that training job in progress on SageMaker. Let's now look at a previously completed job so we can see what are all the capabilities that the platform has to provide. This is an example of a job that previously completed, and as you can see here, there are a bunch of configurations that were not added by the data scientist, but rather added by the platform. For example, what role should this training run as? What is the volume encryption key that needs to be used? These are details that the data scientist or the ML practitioner does not know and does not have to worry about because the platform enforces it in an opinionated manner. There are other aspects such as the network isolation and the subnets and the security groups that the training has to run on, which are also not specified by the ML practitioner in their configuration, but is rather added on by the platform. In this case, do we want network isolation for this training so that it does not have the ability to communicate externally to other data sources? And we've said yes, we want network isolation for this training run. This is how the ML platform leverages SageMaker Operators and enables MLOps for data scientists in a very easy manner. The other important aspect of MLOps is logging and monitoring. How do we make that simple? The training run that started has now sent these logs in a streaming fashion to Splunk. And Intuit uses Splunk as its internal logging mechanism. And this is something that data scientists are used to. And they can now go and look at what is my loss value, what is my recall, what is my precision, and so on in a streaming manner on a live stream coming from the SageMaker training job that's running there. This is another way how the platform integrates tightly with the existing monitoring and logging ecosystem and ties it with the SageMaker operators. To recap, the config repo of the model has the hosting, the training, and the pipeline YAML files, which are declared by the data scientists, and they can now stitch together an end-to-end pipeline coming from featureization to training to hosting the model, all in a seamless declarative fashion that is GitOps driven. So you have full transparency and visibility into what's going on under the hood while providing the right separation of concerns between platform and the data scientist only has to focus on this, which is their code repo, and write fantastic models. In summary, the Intuit's ML platform is built towards enabling GitOps practices in a cloud-native pattern, and we want to enhance these by using Kubernetes native operator patterns so that we can then build a model dashboard, which is one place for everything. To do control actions, statuses, logs, and metrics, all of these in one place so that a customer does not have to jump through multiple tools in order to understand what's the operational state of a model. This also allows for easier maintainability. And last but not the least, we do have an aspiration to open source parts of the Intuit ML platform so that the wider community can benefit from the work that we have done here at Intuit, integrating it with SageMaker.
Thank you, Srivasan, for that amazing demo. It's really exciting to see what Intuit has been building on top of our SageMaker operators. We want to close out this presentation by really acknowledging many of the partners at Intuit who were not on this presentation, and also the engineers, the marketing teams, and the many product managers who helped make this product and also session possible. And with that, thank you so much for tuning in to our session on leveraging SageMaker operators to build machine learning platforms. We want to really thank you for your time and for tuning in to your really valuable sessions that are here now during reInvent. And please do fill out our survey. This helps us improve our content and ensure that we are really showcasing tools and ideas that can help improve our customers' ability to do machine learning at scale.